Have you ever wondered if there is a magical tool that could instantly tell you if your software is absolutely perfect and doing exactly what it is supposed to do? Static analysis is an amazing tool that scans your code without running it, catching many potential issues like syntax errors, security vulnerabilities, or violations of coding style rules. However, it cannot find logic flaws because it lacks an understanding of your program's intent or business purpose. Logic flaws occur when your code is syntactically correct and runs without crashing, but it produces an incorrect or unexpected result because the underlying algorithm or design does not match the problem you are trying to solve. The core reason static analysis cannot detect these errors is that it operates solely on the structure and syntactic correctness of the code. It identifies known patterns of bad practice or potential runtime issues by examining the code itself, much like a grammar checker finds grammatical errors in a sentence. It does not possess the human or business context to know what the code is supposed to achieve. For instance, if your program is meant to calculate a 20% discount but instead calculates a 10% discount, the code for calculating 10% is perfectly valid from a static analysis perspective. The tool does not know that 20% was the correct figure. To effectively find logic flaws, you need to employ complementary strategies that validate your code's behavior against its intended requirements. Comprehensive unit tests are essential, as they verify individual components with specific inputs and expected outputs, immediately highlighting if a calculation or process is incorrect. Integration tests then ensure that different parts of your system interact as intended, while system and acceptance tests confirm that the entire application meets the user's specified needs. Moreover, thorough code reviews by human developers remains invaluable, as human understanding of the problem domain and requirements can spot subtle discrepancies in logic that automated tools cannot. Consider the concept of the oracle problem in software testing, which highlights the difficulty of determining the correct output for any given input, especially for complex systems. Static analysis tools do not come equipped with this oracle. They do not inherently know the correct answer for your unique business problem. This is why techniques like specification-based testing, where tests are directly derived from detailed requirements documents, become so powerful. They create a concrete definition of the correct behavior that can then be compared against the actual code execution, revealing those tricky logical errors. While static analysis is an indispensable first line of defense for code quality and reliability, it is only one piece of the puzzle. Detecting logic flaws requires a holistic approach that combines rigorous testing against explicit requirements, diligent human review, and a clear understanding of the problem domain. By integrating these strategies, you ensure that your software not only functions technically without errors, but also correctly and effectively fulfills its intended purpose, delivering real value.
If this helps you fix faster, like, subscribe, and keep debugging with us.